serving as a solution consultant at VIAS 3D. With over 5 years of experience in RF design, antenna engineering, and electromagnetic applications, he brings deep technical expertise to the field of advanced communication systems. Dr. Yogesh has worked as an RF design engineer in Hyderabad and an antenna electromagnetic engineer in Ahmedabad. And for the past 3 years, he has been supporting industry and academia through high end EM simulation solutions at VIAS 3D. He holds a PhD in Communication Engineering from VNIT Nagpur, MTech from IIIT DM Kanchipuram, and BTech from MIT Aurangabad, and has published more than 17 research papers in reputed SCI and Scopus venues. His strong background in RF systems and EM technologies makes his presence invaluable as we explore V2X beyond 5G trends, technologies, and future directions. Over to you, sir.
Yeah, thank you.
You can share, sir.
Yes, thank you, sir, and ma'am, for the introduction and the opportunity. I will share my screen. Let me know if you can see. Is my screen visible?
Yes, sir.
And just check whether slides are changing or not. 1 minute. Is my slides changing?
Yes, sir.
Okay, thank you. Okay. So yeah, welcome you all onto the session of electromagnetics analysis. Innovation without limits of means antennas and RF designing for vehicle to anything communication. Let's say for electronic software, which is a CST studio suite, we are limit our discussion to that. Meanwhile, if you have any doubts or any questions while presenting, you can unmute and let me know. We are mostly focused our session onto electromagnetics things, wherever antennas are being used. Again, considering automotive industries or vehicle-to-vehicle communication as well. Today's agenda is I'd like to start with electromagnetics. What is electromagnetic is? What are the main parts of an electronics? We'll focus on one of the application, which is the antenna. Most of the analysis we do, which is antenna placement and antenna array things. There is one dedicated tool in electromagnetic, which is antenna mega. So we will focus on that aspect also. Some of the key challenges when we go for a product development or any research and development, if you're doing, as we have multiple electronics which are available in any one of the automotive industry. So we'll focus on that also, considering SAM, which is system assembly modeling, and co-side interference identification. And we'll have some summaries and Q&A also at the end we will have. If not, then middle of the session, if you have some doubts, you can let me know also. So to start with the introduction, I'll just hide these. Okay. So we'll start with the introduction. What is electromagnetic, from where it started? So we know means like electromagnetic phenomena deals with all types of electromagnetic component. When we talk with respect to the frequency, we know it starts with the static tilt errors, frequency range. All these components will come under electromagnetic thing. And again, we can simulate these all components also. Started with a static, which is like low frequency or 0 hertz, we can say a DC. If you comment about the application, something like a touchscreen devices will come under the static frequency range. If you comment about the application, going into the higher side of high hertz and kilohertz frequency ranges, we have applications like a transformer and wireless charging devices. Going ahead in megahertz, gigahertz, and terahertz frequency range, the applications like RFID tags and some of the megahertz frequency antennas. Then at gigahertz, we have the application like a mobile phones, and at terahertz, we have the photonic devices. So these all electromagnetics will divide depending on the operating frequency, what they are working on. Now talking about the connectivity devices, when we see any electromagnetic devices, connectivity plays very vital role. So whatever we see, or one of the biggest useful element which is in connectivity is the antenna, which radiates electromagnetic waves and will act as a transmitter and receiver devices also. So if you see any applications like autonomous driving vehicles also, where you have multiple antennas or sensors, I can say, which is bounded by any vehicle. When we talk about again electromagnetics, we have multiple units also here. We have the PCBs, RF radiative elements, and sensors also. But again, we'll again limit our thing into the antenna side only, where we have this radar, ADAS radar antennas, sensors, video camera sensors, GPS, laser sensors, and like that way. When it communicate with the satellite, we have this satellite different antenna units where vehicle communicate with the satellites, where we have this GPS or tracking systems, grounding stations, base station, UHF and VHF satellite devices. When you talk about a mobile phone as application, then we have this 5G and IoT things which come under this antenna aspect. If you take any a small example also here in this case, which is a BIMI projector, you can see here on the screen, which is bounded by multiple RF unit, where you have this aluminum frame, projector units, batteries, electronics, and the speakers. So when we design any product, we need to consider all these components which makes the electromagnetic wave effect. So if you have electronics, in our case, it may be antenna. So once we design that antenna, when we have these reflecting units like a projectors or a battery, degrade or change the performance of our antenna. So once we do total system analysis or any simulations, if we are doing, then we have to worry about all these core simulation components also, which make our antenna performance change. So if you see during this process, we have to work on multiple things where we have the portfolio or workflow, how we start simulation of any RF component. And at the end, when we limit our thing into the antenna, we have to do the simulations called as the antenna placement, where we see once I'm going to place my antenna in exact location into any application, how my performance of that antenna will be there. So that will be the end things for antenna engineer, I can say. If you take any other example of something like these speakers also, where which is bounded by multiple RF components, like they have the IR sensors, USB devices, uh, Bluetooth devices, Bluetooth antenna, Wi-Fi antennas, and multiple RF components. Again, battery is also very vital to change the performance of electromagnetic wave. So all these are application oriented. So if you take any examples also, everywhere the electromagnetic waves are there and it affects the performance of your antennas also. So if you see this, the key challenges when we are going for any product development, we can see if you take mobile phone as one of the example also, which is bounded by multiple antenna units, PCBs and all. If you count, we can see in mobile we have these 5G antennas. If it is LTE, then we have these 4G LTE antennas, Wi-Fi, GPS, GSM, DCS, and again 4G LTE antennas. So which is bounded by more than 10, 15 different types of antennas. If you take a small example of mobile phone also, and which make the product very challenging to do its performance because of the interference are happening due to the nearby radiative element. So we have to do the core simulations also, where we have to check how much amount of interference is happening once I excite, let's say, GSM antennas. And if you see this Wi-Fi antenna, which is looks like a inverted F antenna, so how much amount of interference is happening. So like that, when we talk about the product development, we have to see all these interferences. Again, means like at the end, we have to very much easily place this RF component into a particular areas. And once we come up with the hardware, we have to go for EMC test setup, where we do radiated emission simulations. So if you go here, we can see like how simulation will helps you. So if you go directly into the measurement stage, we know means like 50 percentage of electronic product will fail once we go directly into the measurement. So it is very much essential to go for a simulation before going for direct measurement setup. Now, if you go for again one of the example, which is automotive industry for a car, uh, if you talk about the components which affect electromagnetic wave is like a sensors. Multiple sensors will be placed inside a car. We have a battery unit, electric devices, and drives. Mainly, we have these antennas, control units, and a cable harness also. Mostly, we have seen in the automotive industries, their R&D is going on to reduce the weight of the car. And we know means like if you see 50 percentage weight of the car is due to the cable which are available inside a car. So to work on or to do any R&D into any vehicle, we can do this cable harness analysis also, which is very much important. Now this is one of the small example for what are the components are available when we talk about uh, vehicle. Hopefully this audio is can hear it. So we can see here how any car can be designed connected with CATIA, electromagnetic CST, and abacus for structure analysis. So like this, there are multiple things when we take any example into the automotive industries or anywhere. We need to worry about all these aspects also from started from the designing till the final stage of that device. Again, design will play wider, very vital role. Then again, electromagnetics will be there because most of the components which are available in any car is electronic devices. So same things applies for costing also, how it goes year by year once we do electronic performance into that. So in the current market, if you see, like means where innovation is a preliminary task for all the automotive industries, we can see like 80% of automotive innovations are driven by, or most of the drivers are like electronics and the softwares which are uh, combined available in any device. Again, mechanical component is very much essential as well, but with that, electronics also are booming in the same ratio here. So to take the today's outline of the communication is like we are seeing uh, into the electronics thing. These are the three things which are like radar, where all the antennas will be available. Then we have this connectivity where we see how a device will communicate with each other. And external performance away from the car, how our electromagnetic waves are being radiated. So if you talk about antennas, so where we found, where are the antennas? So if you take any industries, started from automotive, aerospace, marine, offshores, high tech, robotics also currently, and the space. Most of all industries we can see to do the connectivity between individual elements, we need to have antenna to be there. So we can see like antenna is everywhere, and it is an essential product when we do any analysis. Uh, we'll go one by one, started from a car where we can see like sharp fin antenna will be placed on the top of that. So again, it is top as a rooftop antennas also, where we have these multiple antenna units will be placed. Again, to have a safety when we talk about electromagnetics environment or the space also, it is been covered with a radome. You can see here something like this color. Outside boundary is nothing but a radome, which gives a shieldingness for your antennas from the environment or climate change, I can say. So all these analysis we can do it in electromagnetic simulation software, which is the CST. Again, away from that, we have multiple antennas also, which are placed inside any automotive industry. Again, it starts with how means like our antennas and its shape will look like. It starts from there with again operating frequencies, gain, and all. And where should I put that antenna also plays very vital role, because to do proper performance of a communication, we need to do the antenna placement simulation. Again, it is not limited to only for this car. Wherever we are doing, if you are working on MIMO antennas also, if you have two individual elements, we need to keep one beside another, where we have to put the another antenna. That is where means like antenna placement will plays very vital role. Again, once we identify the location, whether once we keep that antenna into particular location, whether still it will work or not. So final click we have to check once we keep our antenna at exact location. So then only we'll get the certification from the automotive industries wherein we can place this antenna in this particular location. So we can see here, you can very much easily by naked eye we can see how the performance is changed. So performance of an isolated antenna, you can see once I simulate an antenna with a radome, which is a casing for our antenna, you can see how much perfectly I'm getting a dome shape antenna radiation. But once we are going to place antenna on any real-time environment, you can see the performance of that will be degraded. So that will get the very much good idea at the simulation stage itself, where I can place my antennas into a real-time environment simulation. So these are called as the real-time environment simulation. Again, applies for all. If you're working for any application like a smartwatch or wearable devices, everywhere you can do the antenna placement simulations where you can import the casing of a car and you can place the antenna in particular location and you can see how my antenna performance is there. How this can be done, or again, here there are multiple things will come into the picture. I'm going to showcase one of the antenna array concept, how antenna array can be simulated in CST Studio Suite. Here we have multiple environment will come into the picture, started from a single unit to array, how it will be created. Then it is bounded by casing unit. Once I excite individually or cumulatively, how the performance is changed. So everything we can see in this video. So here we'll have the excitation by grouping, wherein we can excite a particular group with the same phase, and if you want to excite another with a different phase, so like that grouping also you can do it in CST. Hopefully you are aware about CST electromagnetic simulation software. If not, then if time permit, I'll show you how these things can be done it in real CST also. Here we can do the excitation part also, how I want to excite this. Same thing, you can import the excitation pattern also into the CST. Same way it applies, means like to all the individual elements. So like you need simultaneous excitation or individual, you can select that also over here. These are mostly required for phased array antenna concept where we have to steer a beam in this. Simulation part, you can have individual or array simulations also. Here you can see this is nothing but a casing, which is a radome in our case. Then we have the PCB excitation unit and then antenna units also. And once I give the excitation, you can see our final product will be available over here. And you can select here which way of excitation I need to do. I need to excite all these array element with the help of simultaneous excitation or the sequential excitation. So everything inside a single environment, we can see we have this casing, the excitation units, radome, PCBs and all. So everything can be imported inside a single environment. And we can see how the all these meshings will be available. If you want to give any user defined mesh, that is also are available, called as the local meshing. So that is also you can give it here in this one. I'll not see stop here, but directly we can see the result, how the radiation pattern is there of individual elements can be seen, and combined also we can see here. This is nothing but the combined excitation of our array structure. There are some post processings are also can be done, and we can see after post processing how the performance is there. Copolarized wave, cross polarized wave, both we can see. So theta equal to 0, theta equal to 90 cuts, all these things can be very much easily evaluate with the help of the CST software. One of the add-on feature I would like to introduce here, which is the array task. Those who are working on antenna side, for those, this will be very much important, how array task can be used here. So firstly, as we always used to design a single element, we can process with that. After creation of a single element, we have this array task which are available here. You can see on the screen, left-hand side array task. With the single click, we'll get a new pop-up window. We can select the shape, which shape I need my array to be in, diamond shape or hexagon or octagon or circular or ellipse. So like that way, we can select any one of these shapes. So I need this type of array to be created. You can select that along x-axis, like means here along x-axis, how many elements I'm looking for, and along y-axis how many elements I need. So like that element number we can give here. If you need some any additional spacing between individual elements, you can assign it from here also, which are available here on. You can see. And there is something called set active and set passive. This is very much important. So if you want to excite all the element which are available in the array, you can set all as active so that you can give any phase shift if you want and all. If you just need that to be passively available so that you no need to excite that elements, so you can make all these elements as a set passive also. Okay. So that way you can keep these elements as a set active and set passive. Now, very much importantly, those who are working on phased array antenna concept, they need to excite the individual elements with a different pattern. Okay, there are multiple patterns are there. Once we excite these see, antennas. So here in this case, you can see a Taylor pattern is being used, and different phase shift and bits and all unit excite and all. So that all information we can feed it over here, and we can use what are the patterns I'm going to use. So in this case, you can we have this here Taylor pattern, but again we can import any different excitation pattern also to do that. So this way you can have importing things. If you want to excite from outside of this one, we can import using the .tsv file. And how tsv file can be created, you can see it here. We have the sum of the positions, excitation, and rotation of the elements, how you need, considering thetas and phi. Again, this is very much important. I'd like to divide this into the system level analysis. So if you have a system which is very good and high end with GPUs and hardware acceleration and everything, so in that case you can go ahead with the full array simulation task. But if your analysis or system is very small in the configuration, which is very much difficult for you to simulate the big structure, so you can go with the unit cell analysis also, unit cell analysis of an antenna also. Again, I would like to touch upon one more point, which is a metamaterial analysis. So for those who are working in that aspect, they need to set up this boundary condition as a unit cell also. So same thing you can consider here, which is a finite element analysis thing. So again, there is one more synthesis unit thing, which is antenna makers. Those who are working in the industries and new for antenna engineer, this antenna synthesis tool is very much important for them, where this antenna megas is having multiple antennas, inbuilt antennas. So you just need to give your inputs. Let's see if I have here. No. So you just need to give some of the inputs, like what is the operating frequency of your structures, what are the click goals you have. So if you give that inputs, I'll just see if I have PDF with me. Yeah. If you can see on my screen, so these are the inputs you need to give. And depending on that, depending on the selection of applications and all, you can get multiple antenna units on your screen. Okay. And you can straight away just click on that and you can export that 3D structures also inside a CST. Okay. So that is very much useful for those who want to design multiple antennas in small time, mostly for industries where their operating frequencies and bandwidth will change continuously. So for those, this is very much important. Again, in the antenna megas, we have this antenna synthesis for phased array antenna concept. If you want to tilt a beam in a particular direction, if you want a beam steered things and all, so how much amount of phase I need to give and all. So you just need to give that inputs, what is the layout you are going to use and all. So once you give that inputs, you can come up with directly 3D structures and you can export that into a CST. Array can be into a conformal shapes also. You can select any one of these shape like a parabolic or sphere or cone or anything like a conformal circular segment type also. You can select I need my array to be in this particular shape. So depending on your inputs, that array can be created by antenna maker. So again, manually you don't need to design this type of complex antenna unit cell. And at the end, as we have seen total array excitation things, uh, in CST you can have something called sequential excitation, where you can excite all the ports with different excitations and all. And at the end we can see, let's say I have this many, around 21 different elements, and I need to see the performance of individual also. So like this excitation with this, we can see also how my eighth antenna is been radiating, or 11th antenna is radiating, or 21st antenna is radiating. And a grouping of that also we can check how it is performance is there and all. Okay, hopefully this is understood for all. Now, if you go into a vehicle connectivity devices, if you take any one of the antenna, which is a Bluetooth antenna, 1 minute, yeah, Bluetooth antenna. So in a vehicle, whether whatever Bluetooth is been placed, whether it is covering all the units or not. Okay, so let's say you have Bluetooth devices which is located at a particular location. How your field is traveling, you can do that analysis also in CST Studio Suite. Let's say our Bluetooth device is operating at 2.45 gigahertz. With the help of electric field excitation, we can see where are my electric field is traveling. So you can see here in this case, our Bluetooth has been placed over here, and its electromagnetic field is going in this direction particularly. Very much easily you can see the strong waves are going on the top side of the car also. So this is when there is no any human or any person is available in the car. But let's say when there is someone in the car, so you can see once it has been there, your electric field is changed. Very much visually itself, we can cross check the performance of both. But once we come or communicate with the human body, we have to see whether the electric field, whatever it is generating, it is hazardous for human body or not. That called as the SAR analysis, which is a specific absorption rate analysis. Again, this analysis also you can do it in CST. Okay, hopefully this is understood for all. Again, what we are discussing is one of the capabilities also, which is available in CST Studio Suite. Again, as we have seen in any car, we have multiple antenna units and PCBs are available. So we need to go ahead with co-site interference analysis also. Again, it is, we are limiting our thing with respect to car, but again, same applies for all the industries. If you are working in any automotive or space or aerospace or marine, everywhere you have to do the co-site interference analysis. Okay, I think someone is writing something. Can we erase this? Can we remove these lines?
No.
No, something came on the screen.
Option disabled only, sir. Option is disabled only.
Disable?
I disabled the writing options actually.
I think someone have written just now, so but I'm unable to remove it. I'm changing the slide, still it is there.
Oh.
I'll do one thing, I'll stop sharing and then again share back.
Yeah, great, sir.
Is my screen visible now?
Yes, sir. Yes, sir.
Okay, thank you. So we can see in the co-site interference. Again, we'll see what are the elements are available. We have this Wi-Fi trans receiver device. We have this GPS receiver, then GEM widescreen receivers, VHF antennas, and UHF antennas. So all these are our devices where we have to see how much amount of interference is happening in between these individual elements. and whether it is required or not. We see like electromagnetic interference and compatibility. If it is in in-band, we have to worry about that. If not, then we can ignore that type of interferences also. Then how these simulations we can do? These simulations are possible in SAM modeling, which is system assembly and modeling things, where we have multiple antennas. Okay, you can see here again, this is one of the biggest advantage of CST, where you can have a car, which is a MCAD file, where we have mostly mechanical information. Same thing we can convert into the electromagnetic also. So we can import that car in CST, then it will be created as a like this block will be available here in the schematic. We can do all these individual simulation first. These are the 5 different antennas: UHF, VHF, FM, GPS, and Wi-Fi antennas. And all these will be imported into the schematic of a CST. And if there is any connection are available, we can assign that connection. So again, by drag and drop method also, you can make all these antennas and car available. To place that all these antenna into exact location, we can use something called anchor points in CST. With the help of that anchor points, all these anywhere located antennas will be fixed at particular exact location. Okay, so that can be done with the help of this anchor point, which feature is available in CST. Once you place that, you can see these all antennas will be available. And this 1, 2, 3, 4 is nothing but the excitations which we are going to use. Once we excite, we can see how the S parameter is there. And mostly we see this S parameter with respect to the frequency. And we can see this S22, how it is there at 2.5 gigahertz, as we are talking about the Bluetooth antenna. And at the same time, how much amount of interference is happening. So we can see we have this 1, 3, 4, 5 as a different antenna, and our 2 number antenna is a Bluetooth antenna. Okay. So you can see at 2.2, it is resonating somewhere near about 2.5 gigahertz or 2.49 gigahertz. And once we do the mutual coupling between all these nearby components ports, we can see S21 is below minus 40, 50 dB. So all these are acceptable, right? So like this way, between the interference also we can check and how the performance of particular standalone antenna is there, so that all these can be compared inside a single environment itself. And to do the simulation, as we know, we need to excite that element, and before excitation we have to have the meshing of that. So depending on the solver, all the structures will be meshed. So in this case, around 104 million of mesh shells has been used to simulate all these 5 elements which are placed on a car. And a time domain FIT solver has been used to do the excitation of these 5 elements. Same thing as I told you, we can have these local mesh properties also, depending on how many dense mesh we are required for a particular this thing, we can assign that also. And by zooming in, we can see how this mesh has been assigned. And at the end, how we can see is like how the radiation pattern is there, how it has been covering the performance of that. So we can see very much easily. Let's say GPS at 1500 megahertz, how its radiation pattern is there once I placed inside a car. Same thing as we are working on SAR also. For that, we need magnetic field to be analyzed. So H field can be checked over here also. And we are doing it for Bluetooth antenna. You can see here, like it is red color. It means that very high intensity field is available nearby this mobile phone. Okay. Any doubt till this point? Any questions? If you have, we can discuss.
Audience, any queries?
Sir, can we use HFSS in case of this software? CST?
I'm not aware about the software much for HFSS, but yeah, as we are discussing for CST is having this capability where you can do all these antennas, antenna placement simulation with multiple solver capability.
Sir, with human being, the electromagnetic radiation pattern has changed, right? Suppose if there is an object within a car, will there be any same effect, like similar to the human being sitting there?
Uh, Means like we can create that environment. For sure, the reflections will not be same. Whatever human body will do as absorption and reflections, other reflecting materials cannot do. So performance will change. If there is any reflector is there, there will be performance. And if you use two different conductors also, the performance of all the individual conductors will be different. Yeah.
So any other queries?
Sir, can I ask you regarding the arrays?
Yes.
Sir, in designing arrays, you have shown all the elements and how to give the phase excitations, everything. I mean, or the amplitude excitations or phase things that a separate module is there in CST, and you, I mean, that you can use from there. But if we want to design our own circuit, like power dividers or phase shifters in CST, okay, and integrate with the basic antenna array, and if you do the if you give the individual phase excitations directly, or amplitude excitations directly to the array, you will get certain amount of gain, right? Like,
Yes.
let us say for 1x4 array, for a single element you got like 2 dB or 3 dB gain, and
Yes.
for 1x4 you may get like 12 dB. I'm just
Yes.
saying the example. And
Yes.
if we design our own phase distribution circuit, and integrate with that 1x4 array, right? Does the overall gain of 1x4 previously that we have obtained, like 12 dB, will it be reduced, or can it be maintained as the same 12 dB gain by
Yeah, we
proper
can.
yeah?
We can maintain the same gain. Okay, there are multiple techniques are there to improve the gain.
Is it related to the circuit that we are using to change the phases, or does it depend upon the antenna structure
See,
to
once
improve the
we
gain?
are, yeah, second point I didn't it's like heard, but I'll try to answer your thing.
Right.
See, once we go for phased arena, mostly if you see, if you have zero phase, we'll get the maximum gain. Once
Yes.
we are trying to tilt a beam for 10
Yeah.
degrees or 50 degrees,
Yeah.
from there onwards, our gain is decreased because side lobe generation will be high.
Right.
Okay, so
Right.
what means like one of the solution is like we have to reduce the side lobes. Reducing
Right.
the side lobe again will not give direct 100%. Whatever you are getting at zero, will get it at 35 degree.
Yeah.
What we have to do, we have to do the cumulative interference over there, so that whatever side lobe was there, it makes the constructive interference into your main lobe, and whatever reduction was there into the gain once you tilt a beam, it will add up in that. So yes.
So at 0 degree, whatever the maximum gain that we are achieving after integrating with this circuit is when it tilts to certain angle, the same gain will not be maintained. It can be reduced, right?
Yes, yes,
No
yes.
matter how much optimization we do in the antenna or in the
Yes,
circuit.
yes, yes.
Right.
What
Okay.
circuit do you have? What circuit is a power divider or what?
Like it's I mean, for the phase this thing, we have designed we used a very normal Butler matrix.
Mm-hmm.
Yes, sir.
Understood, understood. Yeah.
So when the beam is getting tilted, our gain is getting reduced apart, I mean, from the gain that we achieved by using only 1x4 array. Okay. After integrating with the circuit, the overall gain is getting reduced.
Correct. Yes.
Yeah. Is it correct? So by
Yeah.
optimizing the circuit, can we increase the gain? That is what my main question is.
We
or does it
can,
depend upon the antenna?
yeah, it depends on the antenna for sure. We need to change the antenna if you want to improve the gain
Okay.
in this case. But once you do the phase array, as I told you, mostly it is due to the side lobe level. So without having a reach to
Yeah.
4, if you are exciting individual or by using the phase shifter, if you are tilting the beam or changing
Yes.
the phase,
Yeah.
we have to use some other parasitics in between the elements so
But
that
sir,
unwanted radiation will be coupled. Yes.
okay, okay, but we already fixed the single element and then we go for the array. After fixing the antenna part,
So
then
after
we
fixing, we
go
cannot do
designing
anything.
the circuit. No.
Yeah, we
So,
cannot do anything after that then, correct?
right, we cannot manipulate the antenna, right,
Yes,
to improve
yes.
the gain. So, my question is whether we change the phase distribution circuit, like Butler matrix, crossovers, and then and then the power dividers, whatever we use, by changing this circuitry, can we improve the gain or not?
By changing, we can change, but it is not like whatever you are getting for normal one will achieve the same over here.
Okay,
Okay.
okay, okay, sir.
Yeah.
I got it. Thank you, sir. Thank you.
Thank you. Thank you.
Any other queries? So you can proceed, sir.
Yeah, yeah. Thank you. So basically, we can see, let's say, if we talk about UHF or VHF antenna, which is working at megahertz frequency range, we can see its scattering parameter or interference between the individual elements also. So our VHF antenna is at 4 and our UHF antenna is at 5. You can see once you do the mutual simulation from 4 to 5, how the signal is there. We can see at 462 megahertz, we are getting the minus 20 around or minus 23 dB of power has been only transmitted from 4 to 5 or 5 to 4. Rest of all frequencies, it is good communication. So something like that co-interference analysis of a placement also we can do. If this power is affecting, which is not good, then we can increase the distance or we can use any like a metamaterial or anything in between this so that there will not be any interferences happening or reduced in the interference can we can do that optimization. So if you see into the vehicle to vehicle communication, you can see here that which is a dedicated short range communication for vehicle safety or the traffic control is like mostly we go ahead with 10-meter what I can say like spacing simulations. Again, both these vehicles are apart from each other at 10-meter. And you can see means like again this is very much useful or important for ADAS radar systems where we have this transmitting antennas and receiving antenna to identify how much amount of gap between the two vehicles are available. Talking about electromagnetic side, we can have these solvers we can analyze with the help of this. Antenna simulations can be done. Sorry, antenna simulations can be done using the time domain analysis solver, and we can export its radiation pattern into integral equation solver thing wherein big structures can be simulated, and this way we can have vehicle to vehicle communication analysis in CST also. Now talking about the connected vehicles, so these are the four analysis I can put it over here, like FM and DAS antennas, multi-band, multi-roof antennas, which we have seen, connected vehicles or vehicle to vehicle communication things, and ADAS radar, which is operating at 77 gigahertz analysis to identify how much amount of object or what is the gap between your transmitting and the object. Okay, so with the help of that ADAS, we can radar analysis, we can very much easily check from where to vehicle is there, how much amount of speed is there, whether we have to reduce or not. That for the analysis is there, but again, electromagnetic side, we can identify that also by placing the antennas into it. Into again vehicle to vehicle communication or vehicle to anything communication, we can do that also in CST. Shielding effect is very much important here in this analysis. Whatever system has been designed, shielding plays very vital role. How much amount of gap between the consecutive vehicle should be there? So that will be answered by your system also here. And this analysis also you can do it in CST, whether you have a bus which has been matched by the integral equation solver, and we have the car as a radiative element can be exported its radiation pattern and see how much interference is happening, or where are the placement should be placed. So this mostly operate at 77 gigahertz. Again, this can be possible. If you want to identify the location, you can see like the here in this somewhere over here, that antenna of 77 gigahertz radar antenna will be placed there. And in the simulation, you can place that anchor points also, or else you can export its radiation pattern as a source in this case also. And you can see how the performance is there and all. Again, how to radars are been checked in CST. You can see it here. The electromagnetic waves will be bombarded on and any device, and then whatever reflections are there from there, it will predict the things. Rays are there transmitting and receiving things. Both vehicles will active their antennas and see where are the another vehicle is available. I'll not go into the sensor part, and because of its frequency, it is a low frequency device. Okay, some hertz and kilohertz frequency range this will be there, but again talk about the capability, you can have this in CST also with the help of that you can do this analysis also. Talk about wireless charging devices for any vehicle, that is also you can do it in CST. How your field is been traveled, how much amount of power has been transmitted to your car charging unit, that is also you can check here. Efficiency of the charging also you can check, and by doing the exact location, effective amount of power can be transmitted from your TX to RX. So all these wireless charging device analysis you can do. If any human body is available or human person is available inside a car, you can check how much whether it is harmful for that or not by again doing the SAR, specific absorption rate also. Okay, again battery simulation also possible here. If you want to identify the induction motor analysis, whatever it is available in any device, so that is also you can check it in CST. Again, as I told you, any vehicles is been bombed available. Most of the weight is due to the car which are available in any car. So again, these are can be simulated in CST. It may be any power line cable or signal cable. All these can be bring inside a CST cable analysis studio suite, and we can see how that communication is happening. And sorry, a discharge analysis also you can do it here because of the heat and the temperature and the field which are available in the car. The electrostatic discharge analysis is very much useful or required once we talk about any cable analysis. Again, this is possible in CST. You can do PCB analysis also, radiated and conducted emission analysis is also possible. I don't know, means like you are interested for REC simulations or not, but again, I can tell you like both simulations you can do it in CST if it is a for PCB level or for system level simulations also. If you have an antenna, in real time, how antenna can perform inside any anechoic chamber with having wood elements and this absorber, that real time environment simulations also you can do it in CST. You can see here on screen both things. This is your real part. This is in software side. You can do that analysis also. Okay. And how emission simulation is there for any product, you can see here by seeing its electromagnetic waves. Again, now I would like to talk about the product which are available with us, which is a CST for electromagnetic analysis, as we discussed regarding the antenna makers, which is a synthesis tool for antennas. And if you're working for waveguides and filter, we have this phase 3D, Spark 3D, and FD3D software with us also. So with the help of CST, what you can do is like you can do all types of antennas and antenna array simulation, SIP analysis, EMI, EMC. Again, these are available here in micro RF and optical part. I would like to talk about the workflow. Let's say taking antenna itself as an example. We always start with the specification, how much should be the size of the device and all. So that will be the specification. Second task will be a designing, where we'll design any antenna unit. And second task is a certification, where simulation will plays a role. In simulation, you can use any one of these solver, maybe a time domain, frequency, integral equation, and asymptotic, depending on the solver. And at the end, once we get the result, how the performance is there, where we see the success and reporting thing. This is mostly a workflow of anything. Talking about importing and exporting thing, when we talk about CST, you can import and export through IGS, tape, STA, and STB format straight away. Talking about 2D formats, you can export and import with the help of DXF, Gerber. If you're working in ADS and Sonet software, straight away you can import and export through that. If you're working on PCB, you can export and import using only with the help of ODB++ format. And if you're working in Cadence, Allegro, or any one of these software, straight away you can import that file also in CST. Why these all varieties is available? Because of the solver capability. Okay, so we have this time domain, frequency domain, eigenmode, mode, integral equation. Multiple solvers are available in CST. So depending on the application, we can select these solvers and you can do the simulation. You can do all these electromagnetic analysis. With that, you can do the circuit analysis also, multi-physics analysis also in CST. EDA importing thing is also available, EMI, EMC, all types of interferences and compatibility thing you can do. Cable analysis is also possible. You can import any ECAD and MCAD files also in CST. Okay, I'll not talk about this. So if you are working for any vehicle to vehicle communication thing, where you have antennas on cables, so some of the time it is very difficult to design this cable or car. Okay, so we have this CATIA solutions. With the help of that also we can uh, do that analysis. So I'll show you this video where you can import any car and cable inside a CST, and you can see the performance of that also. So here you can see we have this material available of a casing of a car. You can import the harness of the device. Here in the CST, we have this 3D experience format, and that can be dragged on so that whatever CATIA models are there can be bring in CST also. Now you can see in this CST cable window how this model can be imported. Okay, and at the end we can simulate that and you can see the performance of that, how my electromagnetic waves is traveling. So this way all these MCAD, ECAD files can be imported in CST. If you're working for biomedical application, CST also supports that. It is having wide variety of biomedical devices or phantom models are available. You can import that and you can see the electromagnetic behavior of that on that devices. So I have multiple things to showcase. Uh, I'll see. Yeah, this is we have talked about. Uh, I'd like to show in CST also how the thing will be there. In 10 minutes, I'll cover this part. And if you have any doubts in that, we can discuss after this. So once you open a CST, you can see something like this window will be pop up and all these features can be listed out over here. Okay. If you are new for CST, there are already simulated models are available. Okay. So with the help of that, you can understand, let's say I'm working on antenna only. You just search antenna here. So in the library, whatever antennas are there, all these 3D models directly can be seen here. Okay. If I want a horn antenna to be used, directly I can download from here. And if I click on this arrow, that file will be directly opened over here. Okay. So you can see here. So straight away, this type of horn antenna, you don't need to design and optimize that. Already pre-simulated, pre-modeled structures can be bring in. If I'm working on array, 1:4 array or 2x2 array with excitation, everything can be seen here. Okay, 1:4 antenna with power divider networks and all. Okay, multiple antennas again, dipoles with a mobile phone. Those who are working on automotive, mobile industries or telecom industries, for those to make our structures to be governed, certified. You can do the real-time analysis also. So you can import a mobile phone. You can place your antenna in any location, and then you can see the behavior of that also. So like that way, you can do analysis in real-time things. So this what I'm discussing is component library is very much useful. Okay, for phased array antennas and all predefined models are here. If you're working on phantom for mobile phone or head communicate head, you straight away you can import from here also. Or an antenna or any antenna can be dual feed antennas with the radomes and all. Okay. So library is very wide. With the help of that, you can learn the things if you are new for the CST analysis. So that is there. I'll just run or show you the way how environment can be created. So once you open this new template, from here you can import or create any 3D structures. So by this way, you can create an environment of a simulation. If you give any frequency range with respect to that environment will be created. Let's say I want to simulate from 0 to 10 gigahertz. Whatever inputs I have given, depending on that, yeah. So this rectangular radiation boundary box will be created. Okay. So and see if it is simulated. So I'll just start simulation to see its performance. Okay, so there are some primitives are there. With the help of that, you can create any complex structures. We have this import and export. What I talked about, any MCAD and ECAD files. So from here, you can import that files also in CST. We discussed regarding the task. If you come here in home, we have this array task option is there. Okay, let me bring any antenna first. We'll take any circular video. Yeah. So let's say you have designed an antenna and you need to create an array out of that, whatever we have seen on the. From here, if you click on the array task, a new pop-up window will be shown on your screen. And as I told you regarding the shapes, different shapes can be bring. So let's say I want to create a hexagonal shape where I have this sides as a, let it be 4. Click on OK. So whatever I have inputs 4. So depending on that, it has been created. If you want to extend that, you can do also. So phase distribution, amplitude distributions, zonal excitation, everything we can give it from here. As I told you, you can go ahead with unit cell analysis if you have limited hardware things. Okay, but if you have good hardware, we always recommend to go ahead with full array task simulation. Okay, here you can select the solver. Let's say transient only we are going to use. Then click on OK. So no need to do multiple things because of the complexity of the design. Here with the help of this task, any complex array can be created also. Again, you can import any .csv file also, wherein if you want a different shape of excitation. You can set up your operating frequency, then click on OK. So you can see with this 2-3 clicks, we have created an array from a single element. Okay, and if you go here in the solver setup and click the solver type excitation list, you can see here we got this more things also. If you want to go ahead with simultaneous excitation, you can click on that, and you can give different amplitudes also. Okay, if you want to go ahead with phase shift or time delay, you can set that also. So yeah, this way you can create if you are new for the array task or phased array antenna things. Okay, our structures is exciting. Yeah, yes.
The radiation boundary, is it predefined or automatically takes the size of the radiation boundary?
It will be predefined. So depending on what your simulation you give. Okay, I'll just go again back to our structures. So whatever simulation, sorry, frequency we give, depending on that, the boundary box will be created. Now you can see here, there is something like this boundary has been created. Let's say I'll change the frequency. You can see boundary box will be changed. Yeah, you can see, right? So we should know what is our operating frequency of our antenna. So for 2.5 gigahertz, whatever should be the gap between along W max and W mean axis, U max and U mean axis, it will be automatically created.
The user need not define the boundaries.
Yeah, no need to define the boundaries, correct. You can see here, like this way. Now we can take some questions as last 10-12 minutes are left out. If you have any doubt or any questions, we can discuss that now.
Is it, Yogesh, is it the student version is available?
Which one? Hello?
Student version is available for the students to do this one?
Yes. Student version is available of a CST.
For how many
if you are
days?
new, yeah, if you want any evaluation things or something like that, we can also work on. Our company can also work on regarding that also.
Okay.
Yes.
Is it FEM based or MOM based, sir?
It is FlexNet. Which one?
Is it finite element based or MOM based?
No. Yeah, good question. We have all the solver techniques here. Okay. We have this time domain, which is backed by the FIT technique, which is finite integration time domain technique. We have FEM using the frequency domain, eigenmode solver, MOM, MLFMM techniques, multi-level fast multimode techniques. So most of all techniques will be over here. If you change the environment, you can see, as I have shown on the screen, we have multiple solvers are available. Okay, and again, all are backed by the different design techniques. I think we have more than 24 different solvers. Yes, MOM is also there, and MLFMM. SBR technique is also there, which is shooting and bouncing ray technique, which has been useful for your RCS calculation. Those who are working in defense side, they need this SBR technique to be used. So all these techniques are available.
The system requirement for installing the software?
Huh?
System requirements for installing the software, sir.
Minimum like 8 GB or 12 GB of RAM should be there. Again, if it is good, it will take reduce in the simulation time also.
The maximum number of mesh elements it can handle, the software.
Yes. Yeah, there is in million and billion of mesh can be handled here. So if you are new, if you want to check how much amount of hardware requirement is there, this is the link where we can check what is the process requirement, how much is the RAM requirement for that. So minimum here it is 32 GB, but this is industry focus. As a researcher, if you are unable to gather this much, you can have this 16 GB of RAM also. So again, which hardware to be selected, how much amount of memory should be there, GPU computing things is there. So if you need anything information related to that, you can let us know. I can send you that.
Okay, sir. Thank you.
Anything else? Questions?
Audience, any other queries?
Is it possible to design an arbitrary shaped patch?
Yes, yes. There is no limitation. Means like all the complex structures also can be designed in CST. This is again it's like very good questions. So you can see it here. Any shapes can be bring or can be designed in CST. We have this rectangular patch, cylindrical shape, porous shape, cylindrical tabs and all, elliptical shapes and all. So with the help of that, anything you can design. Again, it is not limited. We have these curve structures are also there. So with the help of that, any shape curve you can create, and that shape can be created into a 3D also.
So for defense-oriented application, which type of antenna is used?
Which one?
Defense-oriented application.
Defense
Which
means you
type
need
of,
X-band antennas, 8 to 12 gigahertz of antenna. Okay. 8 to 12 gigahertz is mostly used by defense sector.
okay.
Yes. Yeah. Anything else? Question?
Audience, you can put it in the chat box also, any question. Madam, you can conclude now.
Okay, sir. Sir, the clarity of your explanations and the real world perspectives you shared and the enthusiasm with which you have addressed every concept and the queries have might have greatly benefited all the participants. We sincerely appreciate the time you have taken from your busy schedule to guide us, sir. Thank you, sir. Thank you for your exceptional contribution and for inspiring knowledge. Thank you very much, sir.
Thank
Thank you,
you.
sir.
Thank you.
Thank you, sir.
Thank you, everyone.
Participants, please wait for 5 minutes. The international speaker will join.